Next section topic is calculating a cross product. So in the definition there, you've got uh, the method for calculating it. There's a formula to do so, and the math for that, where that formula came from, is on page 165 in your book, actually just above where this definition comes from. Now, the dot product calculated basically turned two vectors into a scalar. The cross product is actually going to generate a third vector, which is orthogonal to the two that we're given. Now be very careful because both a dot and an X have historically been used to connotate multiplication, and that's not what you're doing here. So just keep the context in mind. All right, so in order to illustrate how this formula works, I'm going to do a problem from the homework, page 184. So we're given two vectors, and we're looking for the cross product of the vectors in component form. All right, so we're just going to use this formula here. So U cross V. All right, so our first point, we want U2 times V3. So that gives us a 2 times a 0. Subtracting U3 times V2, that's -1 times 1. And that is our first component to the vector. Now the next part, the middle part, is we're going to subtract, and we're taking U1 V3. So again, U1 V3 would be the 3 and the 0. That's where those are coming from. And our other point, and we need to at least a bracer on or something like that. U3 times V1. So -1 times 1 again. That's the second component. The third component, U1 V2, subtract U2 V1. All right, so a little bit of arithmetic. 0 and minus and -1 is just 1. This will be all minus. We have a 0 and a +1, so this will become a -1. And over here we have 3 minus 2, which is also 1. So that will be our cross product. So U cross V, 1, -1, 1 will be orthogonal to the two vectors that we have.